Would you agree? So that's how we can find it out. So that's step one. And step two is what? It's just plug it in. So we know that VB equals VA plus VBA. Now VBA in this case, because there's an angular motion, there's an angular velocity. So this actually equals to VA plus omega is this omega cross RBA, right? And we learned this from what? From general motion, correct? Now, if you look at this expression, what do we know? We know VB from step one. We know VA from step one. And we just established VA. We just found it, correct? We just found this VBA, which is this. So can we determine this omega here? Can we determine it? Yes. Yes, we can do it. Because we know VB, we know this. And we just plug everything in. So here, let's everything equals to VB is VB. Okay, that means in the end, there's only one component in the z direction. So here we have what? VA is 15 I plus this I j k, and you're going to have omega x, omega y, and omega z, right? That's what we said for this omega, which is this one here. And what is RBA? RBA is this one we just found here. That's minus 2, positive 6, and minus 3. Correct? So this is our formulation. This whole thing must equals to only this. So from here, we can actually write 3 conditions in different components in the x, y, z direction. So the first one is what? Is the x direction component. We just take a look at the I component. So what is the I one? So first, and I'm going to write something like this. So the first one is in the x direction 15 minus 3 times omega y. This times this times this is positive, but this, remember, this is negative minus 3. So the whole thing is negative 3 times omega y. So this direction is positive minus this direction, right? So which is negative 6 times omega z and all of these will contribute to the final value in the x direction subjected to the unit vector I. Now, what should the value of this one be? Because I said this whole thing eventually has only one component in the z direction, so this must be 0, correct? Because there's nothing in the x direction. There's nothing with I, so this must be 0. And the same thing with what? Same thing with j. Must be 0, except for k, this whole thing will become BB. So here, let's look at the j component. J component is this, j times omega z times minus 2, and this must be positive. So then minus 2 times omega z, positive this one, and negative go this way, which is j times omega x times minus 3, and put a negative sign. So this is going to be positive 3 times omega x. Again, there's no y component here, so this must be 0. Correct? And the last one, which is k times omega x times 6, and this is positive. So it's going to be 6 omega x, this times this times this is positive, minus this times this times this. because there's a minus sign, so we'll make this -2 becomes +2. So that's going to be +2 times omega y. This must be what? BB. Would you agree? Right?
Yes.
Okay. So now let's look at this. How many unknowns we have? How many unknowns we have? We have 4 unknowns: omega x, omega y, and omega z. Last VB. Correct? So we have 4 unknowns. And how many conditions we have? We have only 3. So that means mathematically you need 1 more condition. So what's that 1 more condition? The 1 more condition is this. The angular velocity that you define relatively with respect to this AB must be perpendicular to RBA. Why do we say that? It's because when we define, suppose you have an object moving like this. You said that we're going to consider the motion. This thing is going to spin. So we say that this thing is going to spin in this direction. Right? And the direction of the rotation of this one must be perpendicular to the plane of the object. For instance, if you want to consider spinning of this eraser, let's say I'm going to spin like this. If it's spinning in this scenario, and the axis of rotation must be perpendicular to this plane. That makes sense? Just when you have considered spinning like this. So what's the axis of rotation? It's perpendicular to the plane. Correct? So the same idea here. If you want to define the angular velocity here, and this angular velocity must be the angular velocity perpendicular to the plane of AB. It must be perpendicular. Otherwise, this is actually how we define angular velocity, even though that this bar AB is not perfectly on the plane XY or the plane YZ or the plane XZ. It's not on any of them. So it forms actually its own plane. But the omega you define here must be perpendicular to its own plane. That's how we define omega. Right? Which means what? Which means that, in fact, you can actually test this one with all this observation on all the examples that we did before. Because if that's not the case, that means the omega you define is not really the omega for the object you consider here. Now, because this omega must be perpendicular to RBA. That's how we define the angular thing. Sometimes we solve the 2-dimensional problem. I just tell you that this is the omega. However, if you write omega in the vector form, the direction of the omega must be perpendicular to the plane of your structure, right? We did that for many of these angular motion problems. That's why this must be true. Now, if this is true, mathematically, I can say that omega dot RBA must be 0. The dot product must be 0, as we know. That's the condition for the perpendicular relationship between 2 vectors. Right? Now, if you do that, which means that you have the vector, and this is the omega, this is the RBA. This one, you just dot this one with so how do we get this one? The dot product between 2 vectors is the x component times x component plus y component times y component, so on and so forth. So the first one is omega x times the x component of RBA. This is the RBA. So the first one is -2 omega x plus 6 omega y minus 3 omega z. This must be 0. So m omega x, y, z are here, and this the coefficients -2, +6, and -3 are basically coming from RBA. So that's dot product operation, right? So this is the fourth condition we have. Now we have 4 unknowns and 4 conditions. We can actually find out who they are. Okay. Now I'm not going to repeat this process, but I will give you the hint. How you solve this kind of problems. First one is, the first step is always substitution. You find any condition with only two variables. Now, if you look at these two, you actually have what? Out of the 4, 1, 2, 3, 4. Which one should we start with?